Mr. Pungabgar. I'm from Petro Gramano Secondary School. I would like you to assist me with this question.
That means that y is equal to 3 multiplied by 2 to the power of negative 1. So that's 3 over 2. Remember, 2 to the power of negative 1 is 1 over 2. So we get 3 over 2 minus
the one below.
Might as well put that 6 over a denominator of 2. So we get...
It says, in triangle DXZ below, AC is parallel to XZ and BP is parallel to DZ. Okay, so AC, this line here, is parallel to XZ, and BP, this line here, is parallel to CZ or DZ, this whole line here. Okay, DY is drawn to intersect AC at B. So we have this line DY that intersects AC at B. And there's only one question that we have to answer for this. It says, prove that BC over YZ. So we have BC over YZ is equal to DA, which is this line here, over DX, which is that whole line there. Okay, so immediately when I look at these two here, I see that they fall into two different triangles. Obviously, we've got this triangle here, DYZ, that involves that set of parallel lines. And we have DYX, which involves this set of parallel lines, but it involves the lines we're trying to prove the proportionality of. So, obviously, we're working in two different triangles. We need to find a way to link them, okay? And that's this line here. This side is common to both of those triangles. So if we can find a ratio that expresses this line in terms of the two ratios that we're trying to find, we can equate them. So let's go through this. In triangle, I'm going to work with the right-hand side first. So in triangle DYZ, we can say that DB over DY, short side over long side, dB over dy is equal to, if we're working in this little triangle, obviously we've got dB and BC all over. If we work in the big triangle, we've got that whole side and this whole side, YZ. Okay? And that's already one side of the ratio that we need to prove. We now have an expression for BC over YZ. Okay, so now if we look in this left-hand triangle here, in triangle DYX, we have DA over DX is equal to the same ratio, that DB over DY. And you see now we've got one expression for dB over dy and another expression for dB over dy. So the moment you need to try and prove ratios, guys, if you have two different triangles that involve the ratios that you're trying to find, try and find a side that they have in common, because if you can relate the one side to that triangle and to the other triangle, you can equate them together, which is where this ratio equation comes from. Okay, so that's what we've done here. We've got dB over dy over there, and dB over dy over there. So the moment it's equal to this and that, it means that these two expressions are equal to each other. So therefore we can say, therefore, BC over YZ is equal to dA over dx. Similarly, if I look at this diagram that we've been given here. Obviously, we were given two sets of parallel lines for a reason, so I decided to work with these two. But you could also have gone another route and worked with these two parallel lines, and you could have come across the exact same answer, because then you could have worked with this triangle here, having sides in proportion, YB over YD or YB over BC, and you would still come to the same thing. The reason they gave you two different sides parallel to each other maybe was to confuse you, maybe to throw you off the scent of your ratios. But remember, the moment you have lines parallel to one side, try and identify to which triangles they belong. So these two being parallel to each other, you've got 3 different triangles that you could have worked in to get that ratio proportion.